that bottom part cubed? Help me out. My copy is so light there. I think this is 3. I hope it's copied down correctly.
Yeah.
Now all of a sudden you walk into a math 7 class and they'll play around. And they're asking you to do some calc procedure on this. And in the particular raw form you see right now on the board, it would be crazy to try to get what they want with the way it looks right now. So you're going to go back, reflect back to your math 2, math 7, and say, wait now, I saw Ramsey do a few things in math 2, maybe I can rewrite this, then apply the calculus. And guys, what we're going to do is to apply those properties. There's only 3 properties. Please tell me somewhat, the way it looks crazy, which of the 3, product, quotient, power, just the way it looks, might you suggest we start out with? Samantha? Quotient. It's a quotient. If I rewrite this using the quotient property, which says ln of the numerator, it's rewritten here, we'll get 5x square root 1 plus 3x, subtract ln of the denominator, and that's exactly what she says. She says, Professor, please apply this property. That's what the quotient property says to do. You're allowed to split them up and subtract them. Now you're looking to help yourself out for that calc procedure. You say, now can I use the other 2 properties, got 2 more, somewhere and rewrite this better? Does anyone see a way to rewrite anything at all after the quotient property has been applied? Sarah?
You can use the power property.
Okay, now power property, I see this right here, you're thinking of this as a power, and I agree 100%.
To the 1/2. And then you could put 1/2 in front.
I can, but I gotta be careful.
Because there's a 5x.
Exactly. So it may not be the power property, even though I am going to use power property.
What if-
It may not be wise to use it at this point. It may be wise to use the other remaining property, product.
Wait, what about use the other power?
Right, when I reach it, right here, Sarah's already told me, this 3 can be moved out front.
Yeah.
Definitely, that 3 can be moved out front. I'll do it eventually. But back here, she already senses a problem here. She said, wait, Professor, I cannot move that 1/2 out front as the power property says to do because of this mess here. It has a 5 and an X. I just can't quite do it as easily as I could here with the 3. Can anyone see something that might be overlooked? I think it's a product somewhere. And I can use the product property. Sarah, now go for it.
So there's a product property between the 5x and that radical.
All this, oh, okay. Now tell the class, this is step 1, this quotient. Now tell the class what you might want to do to rewrite, break it up.
Yeah, we're gonna break it up ln 5x.
Hang on now. ln, could I, in fact, break the 5x up also, 5 times x.
Oh, so ln 5.
There you go.
Ln
Plus.
plus ln x
Plus,
plus ln rad 1 plus 3x,
There's
and
a
that
ma-
also can be used.
hang on now.
with the product.
That's a mathematician for you right there. That's product property. Now, we already have this, I'll just repeat this, we still have this on the end. And this was making use of the product property. Now, finally, I think to finish it up, yes, now I see ways to apply the power property. Guys, ln 5 stays like it is. Nothing going on there. ln of x stays like it is. But this, because of this, Sarah, tell me what's going to happen on the 3rd term here.
So you're going to put 1/2 in front of ln.
Beautiful.
And then 1 plus 3x.
That's what I want to hear. And then while I finally reach that last term, students were telling me quickly, even before we got there, I can quickly move that 3 out front, power property, and rewrite this as this. And this is an application of the power property. And guys, at this point, if we have no mistake, there's this mess up here, rewritten. I split it up into four terms. And then if you're doing a calculus procedure on this, it's much easier to do it on those 4 terms than try to do it on the original. So it has been split up, yes?
Can you explain why the 3 goes in front?
Yeah, the power property, if you have the power on the outside, you're allowed to move that power out front. And the power property, I think they used an R, to move the R out front. Yeah.
So is this just our answer for now?
Yeah, you look at it and say, Professor, that's all, I just want you to split this thing up for me, as much as you can. Now, don't get too ambitious. I've had some students to say, Professor, can you not, right here for an example, don't do this though. They say they're gonna get ambitious and rewrite this as ln1 plus ln3x.
No, it's not, it's.
That's a common mistake, you can't do it. First of all, this is not a product. This is not a quotient. I don't see any power. So you cannot apply any of those properties. I don't see that. This is a sum. 1 plus 3x is identified as a sum. Now I don't have a sum property. It's got to be a product, quotient, or power. So do not do this. I've seen some students do it. Leave it like that. We're good. With that said, let's see on that handout there, we had also this one coming up. Let's call this part B from the handout. Have log base 2, and we have x times square root 1 plus x squared. We would like to rewrite that with the help of properties if we can. Now, the way it looks, does anyone know which property might I want to start out with on this one? It was just the way it looks. Lisa?
Products.
Product. There's a product there. Let's rewrite this quickly as, I'll do it on the side. Log base 2 of x, here goes, plus log base 2 of a square root of this. I'll give you partial credit for each one of these. Now, is there a spot now to show more? Or to apply? Is there another property that could be applied here on this or not?
Power.
Power on the end. This can be expressed as a power.
So that would be.
Hang on now. And then Lisa, hang on, I'll get to you. Let's leave that first term the way it is. Log base 2 of x. Now Lisa, tell the class what the red would look like if I applied the power property.
So that would be just 1 plus x to the 1 power.
Tell me what the power property would look like.
Half log.
Half out front. Log base 2 of 1 plus x squared. Just move the 1/2 out front.
Is that why one be multiplied?
I know what you're thinking. You're thinking square root 1 plus
Yeah,
x
I
squared
was
is 1 plus
thinking
x.
it's-
Square, that's not a perfect square root. Square root 1 plus x squared is not 1 plus x. I know you might think square root 1 plus x squared, you say, Professor, that's just, why don't you just write that as 1 plus x? Square root 16 is 4, so square root 1 plus x squared is 1 plus x. It's not.
So it's just a sum, it's not like a base of the power?
No. I know it, I think in your mind, you're looking for square root 1 plus x squared, and you somehow got a 1 plus x.
No, I'm looking at the, just at the powers, I was thinking just to multiply by 1/2, and it will be 1.
Oh, these?
No, it's.
No.
No?
No, you're applying the properties. There's no 1/2 to be multiplied together here. Or 1/2 of 2, or whatever you're looking at there. You guys agree with this? Is that split up with the properties? Split up. And the last one there, I think on that handout, that was finished. If I want to apply these new properties, and logs on that one, coming up, it says log. Guys, this one says 2x plus 3 over x squared minus 3x plus 2. Now, can anyone in this clever class give me a start on, you see that in calculus? They want you to use your free calc first, then do the calculus. Does anyone see anything going on here?
Can you just do
Quotient?
I could use quotient, if you want to jump right into it, use quotient, no problem. Write this as log of 2x plus 3, and this is subtract log of all this, x squared minus 3x plus 2. Quotient property, 100%. Now, this one, see why I've saved this for last, the last problem here. Not quite finished. What is it yet to be done on this? See, David.
You can factor, trinomial.
This trinomial, beautiful. Can be factored into x subtract 2 and x subtract 1.
And then we can use product.
Look at that, and then I can use what?
Product.
The product property on the red. So we're not quite finished. So leave the first term the way it is. We're done with it. But now with the red, and I gotta be careful, there's a minus sign here. On the red, since that's a product, Lisa says use the product property on the red and write this as log x subtract 2 plus log x subtract 1, and then close that up. You guys agree for the red? Product property? And if you really want to finish it up, we're finished. But just to make this look a little better, log 2x plus 3, you could use the distributive property on that minus sign. You say, Professor, I'm gonna write mine like this, if you don't mind. Just taking time to distribute the negative sign and have your answer like that. Now guys, keep in mind, we start here. This was the original. So it's gonna be much easier to do a calc on it, a calc procedure on it, in that form than the original form. Now again, let me warn you, I know my students by now, do not think you can do this. 2x plus log 3. That cannot be done. It does not fit one of those problems. So cannot do that. It's finished. Sarah, go for it.
Would you accept the second one?
Oh, this right here?
Yeah.
Absolutely. 100%. Okay. Done, guys? Now, Aiden, since you're close by, tell me what they're asking me to do in the next part on that handout. Let's call this part C of my work up here.
Right.
They actually split it up for us.
Yeah.
And this time they're asking, wait, I'll split this up for you. Now put it back together. They want us to do it backwards. Now, can you read that to me and tell me what it says?
Yeah. 2 log
Okay, hang on, 2 log,
base 4
base 4,
x
okay.
minus log base 4 y
Oh, wow, log base 4y, okay,
plus log 4 log base 4
okay.
w
Of how much?
w.
W. That's it.
Yeah.
Okay, guys, we're saying, okay, they were nice enough this time to split this up for me. Now they want you to put it back together. One single log. Now, can anyone think backwards and tell me what properties can be applied trying to put this thing back together, Samantha?
For 2 log base 4x, you can use the power property.
Let's move that 2 back up there where it originally was. Absolutely.
Log base 4x to the 2nd power.
Okay, hang on. So we're gonna write this as log base 4 of x squared. Is that cute? Oh, that's just x squared. Tell me more.
And then, for the following one, for that, you can use,
Make it easy.
product property.
I want to say a minus sign.
Oh wait, minus, so you divide it, so that's gonna be quotient, or no?
Yeah, quotient.
Yeah, quotient property,
Now what goes underneath there?
the
It's tricky.
product
It's tricky.
property, so it's gonna be over,
Hang on. Don't look at this yet.
so then it's just gonna be,
I know it's so simple, she's afraid to
Is
say
it
it.
just log base 4 y?
Yeah, it is just y. It's y there. That takes care of this one.
It should be multiplied.
Oh, we're not finished. I'm not finished. That's just the first two terms. Now, though, I run into, and I gotta be careful, I run into, David, to end this, it says a plus, which indicates to me they have used the product property. So I gotta form now a product with that W, and guess what happens if I form a product? Guys, I'm gonna put it right here, times what?
W.
And all that's over y. And you're finished. The math2, thank you so much, is log base 4 x squared w over y is all this mess put together as one single log. And you're done. Read the next one to me.
2.
A 2 up front?
No, it's just number 2. ln
Okay, ln.
Times x over
Of.
of x over x minus 1
Beautiful. Okay,
plus ln
natural log, okay.
x plus 1 over x minus ln times x squared minus 1
Not times, of.
of x squared minus 1
X over,
x squared
x squared.
minus 1.
Minus 1. Cute. And by the way, is that the last one?
Yeah. And then
We got something else down there. Okay, they want us to put it all back together and form a single log. Guys, here it goes. Let me put this in red. ln, just one ln, natural log. Now, this should give you a hint. This should give you a hint.
Product.
Tell me what I should start out with.
With product.
Product. Now, hang on now. So that product's going to be x over x minus 1 times x plus 1 over x. Hang on now. Hang on. That takes care of the first two terms. That subtraction sign says on the end, don't stop there, form a quotient.
Over x squared.
X squared subtract
Minus
1. And we'll block it off like this, guys, so you can see it all. All that put together as one single logarithm looks like that. At this point. Now I'm supposed to clean it up. This is where we might make a mistake. To clean this up, guys, oh, I thought something might cancel. Will something cancel here? Thank goodness. Wait. Will
No,
that
it's
cancel?
not,
No.
no, it's the x.
Okay, so the x is canceled.
Yeah.
So he gave me x subtract 1. I think there's an x plus 1 up here.
X plus 1 over x minus 1.
There you go. And the x minus 1. X plus 1. The x is canceled. So guys, here goes. To simplify this, still ln. X is canceled, so we got x plus 1 over x minus 1. Still over.
We can
Rewrite as what?
as the difference of squares.
Differences, thank you.
X minus 1 and
X plus 1. Difference of squares down there.
X
Hang on now. We'll block this off at this point. Now though, just to be cautious and not jump into it too quickly. This that I blocked off says this. Let me use my colors. That the red, why not? The red is being divided by the black. This is actually what it says is happening.
And it will be cancelled.
Hang on, let me get more work done. The red's been divided by the black.
Yeah.
That means that red, x plus 1 over x minus 1, we'll change this to a times. Now if I change this to a times, guys, what might I rewrite that black as?
1 over.
1 over.
X minus 1.
That's what I want to hear. like division back in middle school. And if I do it like that, as suggested, the x plus 1s are going to cancel. I'm going to end up with 1 over, x minus 1 what, squared?
Yeah.
Wow, so my final answer looks like, still ln's there. At this point, it looks like this.
Yeah.
Look where we started. We started here. And you put all those back together. Now, the reason I saved this one and brought it in, one of my top students came to my office one day when I had him, and every homework problem that was assigned, he did. He's one of those students. Everything assigned, he did. And he stopped by the office. He says, "Professor," and he was checking his answers in the back of the book. And it was this particular problem. And he stopped here. Well, the textbook gave another version of that answer and threw him, and he thought, "Oh no, I've missed the problem. There's something wrong." Can anyone tell me, when you flip to the back of the book, and sometimes they'll do that, they did something else with it, they rewrote it, which just absolutely threw him because he stopped where we stopped right here.
Oh, I know.
Now, can you tell me what the textbook may have done? Lisa?
I think it's like rewriting, like negative exponents.
Hang on. So ln, she says, "Professor, could you not rewrite that like this?" Are those two saying the same thing? 1 over x minus 2 squared is the same as x minus 2 raised to a negative 2. If that's true, then the textbook, applied the power property at this point and brought that negative 2 out front, and they had their answer written like this, which threw that student. I mean, he was really upset because he stopped here and he didn't quite understand how they got this. They had this. They went just a little further. Sarah?
Well, I think in the example, was the answer 1 over x minus 1 squared?
Was it x minus 2 or x minus, did I
think
put
it
2
was
in
x
there?
Yeah, I think it was x minus 4.
Oh. What, was there 1 there?
Yeah.
Yeah, 1. Geez, that's my fault. Talking, trying to get everything together. That's what you're looking at, right? So who would think to do that? He didn't think. He was one of the top students. And who would think that they wanted you to go further? So I've got to be careful when you finally see a test on all this next Wednesday. "Professor, if I get to this point, will you be happy?" I'd be happy. I'd be happy if you stopped here. Now, might it look better in certain situations written like this? Certain cases, it might look better. But my goodness, I'm happy if you understand those properties and how to use them. Yes?
So the form that your student had seen in the answers of the textbook,
Right here?
that was, yeah. So the whole point of the question is like you're trying to break it apart from the properties, but that is adding I think that was like adding the property to it, where you're the power property, where you're simplifying it. But since like we're breaking it apart.
Exactly. That's why I like this right here.
Yeah.
But for some reason, the author of the textbook or the students who worked for him in that textbook went a little further, and that could happen. I thought I'd point out though. I'm happy right here. Okay, so guys, all this mess right here was put together here. Okay, Lisa?
Yeah, just one question, if it's gonna be on the exam, is that like okay to live in this?
That's what I'm saying. You can leave it
Yeah.
as 1 over x minus 1, I think it's squared.
What if you went further and you write the final,
You mean like the negative 2 out front?
Yeah.
Yeah, that's fine. Yeah, that's fine. I'll give credit for either one. But don't be too ambitious and write that in the wrong final answer. No, don't do that. You guys with me on this? The properties of logarithms. That's one big chunk done tonight. Now, I'm looking at my time here. What are they asking me to do at the end?
Solve.
I got to do it. Okay, on that handout, solve an equation. And here we go. Did a beautiful job tonight, guys. Beautiful. Let me erase this. Okay. Read that to me, Aiden. What did they ask me to solve?
Log base 2
Log base 2,
of 3x plus 4
3x plus 4
is equal to 5.
is equal to
5.
5. Then what you solve for x.
You can use the rules.
You gotta use the rules. Now, first, when you say use the rules, actually you have to tell me what does that mean, as we were discussing before the break. This can be written like an exponential. Can anyone tell me what that exponential would look like? And then I can solve this thing. Let's see, hang on up, Samantha.
2 to the 5th
Beautiful.
equals 3x plus 4.
That's exactly what it means. Drop the word log. That's what it means. Now I can solve it. That's middle school. This is 32. 3x plus 4. Good expression, subtract 4. What is that, 28? Doing it quickly. And what is that, 28 over 3? And you're finished. There's the answer. Done. If you have to know what that means, is just rewrite it and drop the word log and write this as exponential. Okay. Aiden, was there another one on there? I hope
Yeah.
there was.
There's 2 more.
Okay, what's the next one?
Log base 7
Log base 7.
of x squared plus 4
Oh, okay, x squared plus 4.
equal to 2.
Oh, okay. Guys, no issue here. Can someone tell me what it can be rewritten as?
7 squared.
There you go. 7 squared is equal to x squared plus 4. I love this when you guys look. And my problem in math and in grad school, I just had an issue with sometimes I did not quite understand the definition. How I could quickly rewrite something. This is beautiful. Rewrite this like this and the word log's gone. Therefore this is 49. X squared plus 4, no problem here. Subtract 4, that's 45. Do a square root. Looks like it's plus minus. And guys, there's no perfect square root for 45. Simplified is, what's 45 simplified? 3 radical 5, is it?
Yeah.
I did it quickly. And you are done. Whew. Aiden, I'm glad I brought this handout worksheet in. What's the last one?
E
Oh, beautiful. E.
exponent 2x plus 5 equal to 8.
Is equal to 8.
Yeah.
Nah. I see why I saved that for last.
We're gonna use the log.
We're going to solve for x. Now we're going backwards.
I'll use the
They
log.
didn't give it originally in log form. The last two had log. This one, though, has no log. Can I rewrite it and put a log in? Can someone rewrite what you see right down the board, but use, I see they're using a base E, so use a natural log, LN. Can anyone rewrite this and tell me what does this look like written in log form?
ln of 8
Hang on now, LN of 8,
equals 2x plus 5.
beautiful, stop right there for now. That's what it means. She said it perfectly. You guys understand why she did that? And why, by the work we did before the break, it can be rewritten like that? Can it be rewritten like that, guys? If it can, I can now get x by itself. Easily. Subtract 5, it's gonna look strange. ln of 8, subtract 5, equals 2x, and then divide by 2. And see if you guys will agree. Does it look like that? Now what's tempting to do in that blocked off answer? What's tempting to do to go a little further and you can't do it?
Just,
I've seen students who are, what's tempting the way it's written to do?
oh.
Some students will say, make that 3. Eight-
No, there's no log for 5.
There's no log for the 5, that's, I can't do anything with that, but I've seen students do that, they get ambitious, 8 subtract 5, I said, where'd the 3 come from? That's 8 subtract 5, we can't do that.
Can we use the log of 10?
No, we're not gonna do that, I'm just asking that 8 subtract 5, it's not 3, that's just a common mistake I was talking about.
Okay.
Also, you might think, can't do it. 8 divided by 2, make that a 4, Professor. Make that a 4. Can't do it. I wish you could. Can't do it. So there's the answer. Aiden, remind me, was that the last one? So the handout is complete.
Yeah, it's complete.
Woo! Chapter 4 is not quite complete.
Sir.
I'm getting ready to start chapter 5 here, not tonight, and check, oh my goodness, not tonight for sure. Here we go. Now I saved all this for last. The handout's done. And I knew I threw those 3 properties at you quickly. I used the properties. I hope you guys get a sense of what it's meant by product property, quotient property, power property. It's gonna take some practice. Now those of you who are doing your homework, and some of my students in this class right here, I've already seen when I check homework, they're doing their homework. Others will have a little paper scattered about. Oh, is this it? And then I give you that strange look. That's all you've done? And then we take the exam and, oops. Not a good score. Not a good score, unless you've had the course before, here, or somewhere else, and you feel more confident that you don't have to do as much homework, and then maybe that is okay with you. But no, I would definitely turn to my homework, and Lisa, I think I gave you the section numbers for all these, so you can turn to the sections in the textbook and look at the homework there, and try some and see what happens, okay? Now, here's the way I'm gonna close now, because I've got limited time here. Yes, go for it.
Sorry, in that problem, in the middle, can you explain why you changed that to log x minus 2? It's right there in the middle, right next to it.
This,
Yeah.
over here,
Yes,
which one?
that one, right?
Right here?
Below it?
Down here?
Yes.
Okay.
Why does the answer change to log x minus 2 minus log x minus 1 when it was plus?
Distribute the negative sign
Oh, okay.
on both those, good question. I distribute that negative sign on both these terms.
Got it.
That's what you, right here.
Yeah, that's
No, I see what you're concerned. Now, right, it's that clock. No. Then when I give you a test on Wednesday of next week, you'll be glancing at that clock, you'll see, oh my goodness, Professor, it's 7:30 already, all of a sudden it's 8 o'clock and I'm not finished with my test yet. And then that test next Wednesday, get ready, bring your lunch, bring the meal. That's gonna take it. Sophia?
What time are we gonna start the exam?
No, it's the regular time. Oh, no, on Wednesday of next week. You're talking about Wednesday? This Wednesday, you've got a short quiz on 4.1 and 4.2.
Right.
No, next Wednesday, I'll let you know more about that. Okay, now here's the way I'm gonna close down. I know we're tired. We did quite much. Let me erase all this. Guys, we did a good job on this. Now, whether or not when you walk out, you practice with this in the textbook, it's gonna take practice. Or you may say, no, Ramsey, I'll just accept what you gave me for my notes, and I'm good. I think it's gonna take a little practice on this. Now, that said, I want to go real quickly, something with you here, and that is sketch this. That's a good way to get this started off here. Good way to close this down. You know, students take a math 2 class, any math class, they say, oh, I'm not going to do too much here, I understand what's going on. No, you're going to do some work here. Sketch f of x is equal to log base 2 x. Closing out this. Can someone remind me the word that I asked you to associate with when you hear the word logarithm?
Exponent.
Exponent. Associate with it has something to do with exponent. This says they want to see a sketch of a log function. Now, before I sketch it, can someone in closing down tell me what does that in the black? Can I rewrite it and express it a little differently, which might benefit me?
Isn't it 2 to the x?
That's 2, hang on now, 2, be careful. Base 2. And before you start thinking about it, hang on. I know and you know, if I ask you log base 2 of 8 means 2 raised to the 3rd is equal to 8. Equal to 3 here. You know those two statements, I know they look so different, they mean the same thing. Now, can you take that little hint and tell me what would this look like? And it might help, you know, f of x is y.
2y equals
No,
x.
not 2y. Close, close, not 2y. 2 raised to the y
Oh, yeah, that's what it is.
is equal to x. Who would think these two are saying the same thing? Those two statements are saying the same thing and close down tonight. I know, me too, when I took a math class, I thought, are you, whoa. You mean when I see this, it might be better to think of it like this? They're the same, they're equivalent. So if they say, now sketch this, I'd prefer to sketch it, look at this. And since I'm closing down, and it's rewritten as 2 raised to the y is equal to x, I'm going to do a table right quickly. I'm closing down. And the way it looks, 2 raised to the y is equal to x. Last week, I replaced in my x column a variety of numbers. This one looks like I should put those numbers in the y column. But those numbers, I think I used these numbers last week. On the other side, it's 2 raised to the y. There's the y. I got the y's. So it says 2 raised to the negative 2. I'll come back to it. This one's 2 raised to a negative 1, trying to form a table. 2 raised to the 0. 2 raised to the first. 2 squared. Let's put those y values in there. That's what it says, 2 raised to the y. So I'll put some numbers in the y column and we'll find out what these are. Guys, by now we all should know this is 1/4. This is 1/2. 1, 2, and 4. Now, I'm gonna plot those points, connect, and see if I can at least recognize before we close down tonight what I'm gonna consider a parent graph for log base 2 of x. What does log base 2 of x look like as a sketch? Guys, here it goes. And we'll see what this looks like. Okay, I got an x, y. Let me see my numbers and see if what I want here. Okay, the y's go from a -2 to a +2. Okay, here we go. That might help. Now start plotting points, guys. This is like 1/4, -2. This one says 1/2, -1. I think it's 1 here, 0. 2, 1. I'm doing this quickly. 4, 2. Let's rewrite lined up correctly, I think I do. Let's plot those points, ordered pairs, 1/4 down 2. Okay, let's do this, guys, 1/4, let's go out to 1, 2, 3, 4. Okay, out 1/4 down 2, just a quick. You put in green, 1/4 down 2 is somewhere in here. My next one says, now move out 1/2 down 1. Move out a little further, it's down 1. I got 1, 0, right here. I've got out 2, up 1, here. Out 4, up 2, here. Get it directly from the table. Connect these. Do I have a sketch that might look something like this?
Wow.
That true?
Yes.
Now what is that? That's a graph of a log base 2 of x. That's all we have at this point. Now, Sarah, remind the class, in closing down, what did this graph look like? I'm placed on the same grid in a different color. Now suppose I'd ask you to sketch this. I'll do it in blue. I did this in green. Green one represents this. Now I'd like to show a graph representing 2 raised to the x, and that's the one I think I did earlier tonight, and definitely last week I did it. Can someone tell me the shape? What was that shape?
It was, well, it was that shape that we have, it's the green but rotated, like,
Something like this?
was it the inverse?
It looks something like that, guys? 2 raised to the x?
Yeah.
Hang on. I heard a student say,
Oh.
Professor, I think these two are gonna be inverses of one another.
Professor.
Yeah, what do you think I'm gonna do next?
Is it gonna be asymptotes?
What do you think, Sarah?
It's gonna be there's gonna be an asymptote, or it's like.
Thank
The
you.
reflection when the graph is
Thank
y
you.
equals x.
Yeah, there you go. We
Yeah.
discussed that last week. Y is equal to x. Straight line, one through the origin. And she's saying, Professor, that blue graph reflected across that line gives you the green, or the green reflected across that line gives you the blue. They are inverses of one another. So 2 raised to the x and log base 2 of x are inverses. Now, here's my last statement. Can someone remind me? I just did one, I think, at the beginning of class. After you find the inverse, like you have to on the quiz on Wednesday, after you find the inverse, how does one check it?
Put it back in the.
No, you don't.
No, it's use the.
What do you do? What do you do?
F
We did,
of-
what we did right at the beginning of class tonight. Yes.
Reflected on the y-axis.
No, how would I algebraically show
Can't you just?
that function is really, they are inverses of one another? What was that? Samantha?
Composite
Well,
inverse.
I feel like there's like 2 things you can either do. You can just switch out check the domain in green. And
Oh, yeah, I like that. Hang on, let me do this, Samantha. The green one. The green one has domain, guys, from left to right,
it's domain is
0 through infinity. Now, this is the green one. The range is negative infinity through positive infinity. Oh, I'm glad she brought this up. Now, the blue one, its domain is from left to right, negative infinity through positive infinity. The range on the blue one, the up and down, 0 through infinity. Compare these, did they actually reverse or
Yeah.
flip? Did they? And is that what should happen for an inverse? The domain and the range should flip. That's what an inverse is all about. The x's, the y's interchange. Is that happening? Yes. Now, here's the way we really truly, I love that, Samantha. The really true check would be to take your function, form a composite with your inverse. All this is with respect to x, and you'd better get That's a check. That's the check you'll be using on the quiz Wednesday. After you find the inverse, you think you have the inverse, now check it like I did, some on, with this on, or at the beginning of the class tonight. Guys, on this one, it flows down, let me do it, since I got different colors here. Oh boy, here we go. I'm just gonna do it the way it is. You're putting the inverse into the original function, or into the f. Okay, guys, what do we want to do here? Jeez. Okay, tell me one. If I take the green and put it into the blue, what would taking the green into the blue, that's a composite. Can anyone tell me what that would look like here? Would be 2 raised to what?
2 to the power of 2.
Log, power of, log base 2 of what?
2 of x.
X. Now,
Are they going to cancel out?
now they're supposed to be by this property. If those are
yes.
inverses, this should be merely X.
How do we check that?
It's like 2 log of 2, it's like
Now,
just.
well, I'm gonna worry about anything else about what it says. That's the property.
But like, how do you-
Now, if, another way to check it. Can anyone tell me what, maybe if you turned around,
Oh.
what would that one, because it should work in the other order also, what would that one look like?
Log 2 of x.
Hang on, log base 2 of 2 raised to the x should also be what? X. So both composites in both directions should be X. And that's what you're gonna be looking at on the quiz Wednesday when you do my one inverse problem. You gotta check it by doing this composite and hope you get X. And that's what this is all about here. I'll do more with this on Wednesday. Guys, congratulations. I think chapter 4 basically is done.
Wow.